Okay, so let's start for today. And in the last lecture, we had taken uh, an overview of pointers that we had already covered in the last semester. So what do we do now from here? So there are now we will move on to the things which are important for us, and out of which perhaps this particular part I should shift to the previous ones, or maybe I can do a new page. Yeah. Okay. So today what we'll do is we'll continue on the pointers only, but we'll take the things which are going to be more important or more useful to us. Okay. Of course, whatever has been taken also is going to be useful, but these are the things which we are going to use now almost daily, and we'll discuss about that. So the topic is essentially what is called as uh, pointers to structures. Yeah. So I hope my voice is audible. So Shiva can confirm if he has joined.
Yes, sir.
Yeah. Okay. Great. Thank you. So firstly, let's talk about the structure, and then let's talk about the pointers to structures. Okay. So I will just write the structure first, and then we will talk about the pointers. So our earlier one only, let's say float x and float y, which are the x and y coordinates. Yeah. So let's say we define like this, okay, and then we define. So this is a declaration. We all know that, and then what we can do is we can have a definition of a particular variable by saying that I have struct point, which is point is the tag basically, and then I will say origin. So this much basically we know that with this what happens is the memory gets allocated in which there are two fields x and y. And then we could write origin. Let's say this is main function, let's say. Then of course I can write, let me say this is part of the main function. Okay, I can always write origin dot x is equal to 0.0 and origin dot y is equal to 0.0. Now the thing is that I want to shift the origin. So I want to write a function which is shift origin or shift point, in which I want to give origin as the point to be shifted, and I want to give two displacements, displacement in x coordinate, displacement in y coordinate. So I want to give origin, and I may have x, let's say x coordinate displacement is, let's say 1.0, and y coordinate displacement is 2.0. So essentially I want the origin, the same origin, this origin now to shift to another point. and this I want to do from the through the function. The problem of this is obvious, we all know that. So if I write code like this, so P is the point which needs to be shifted, and then I have float X displacement, and I have float Y displacement. Okay, and suppose I do something like this: P dot X plus equal to, or rather, if I want to keep things simple, P dot X equal to P dot X plus X displacement, and P dot Y is equal to P dot Y plus Y displacement. This does not work, right? Why it doesn't work? Yeah, it is passed by value. So because it is passed by value, it does not work. So the question is, so of course the answer we know that it has to be passed by reference. So which means that the pointer to the structure needs to be passed. Now the problem is that, and then perhaps over here I will say struct point star P. Okay. Now the problem is that how do I access this X and Y? So obviously, I mean, the obvious thing which I might think of is something like star P dot X is what I will like to write. Unfortunately, star P dot X equal to star P dot X plus X displacement. Ideally, they should have given me this facility, but this does not work. I mean, this is not the way in which we need to do that. And of course, there is a reason behind that. But so this does not work. Okay. So the what works in this case, in the case of structure pointers, is that when you have pointer to the structure instead of dot, and let's say that now this P is a pointer. Remember that. Okay, P is a pointer to struct point. P is no longer a point by itself. So this basically this pointer arrow X is how you access the field. I mean, if you have the pointer to the structure and you want to access the field through the pointer, you have to use the arrow instead of dot. And same thing I have to do over here. Okay. So this is the way. So what we are saying over here is that it is the arrow operator. Okay. It is also called as dereferencing operator. So this arrow dereferencing operator is being used to access the field. And with this, now we will see that, rather we can see that the origin actually gets shifted. This point origin over here, it gets shifted by 1.0 and 2.0. What actually, so the mechanism is still the same. It is the pointer to the struct point which is put up on the stack, and through that these things are this X and Y field of that particular point are accessed, and to which this X and Y displacement which are also passed, they are basically utilized. Okay. So so this is a way in which is one way in which it could have been done. There is another way, of course, that instead of passing and this ampersand origin, of course, I can have a pointer by itself. I mean, why can't have, just like I have integer pointer, why can't have struct pointers? So there is no one stopping from having that. So for example, I may have struct point star, and I will say ptr. Okay, just like we have integer pointers, we can have struct pointers also, right? And then instead of this line, instead of this line, what I could perhaps have done is that I could have said that ptr is equal to ampersand of origin, and perhaps instead of shift point ampersand origin, I could have used ptr. And this is also fine. Okay. So there are these two ways in which you can access the structures through the pointers. Either you pass the address, and in the function inside the function it doesn't matter. I mean, it doesn't know whether this. This is it's anyway whether you pass PTR or whether you pass ampersand of origin. In both cases, you are passing the address to the point origin only. So it doesn't matter. Fine. There is another thing which can also happen. So, by the way, any question up to what I have taken this part? Because if there are no questions, I will move forward. No question? Okay, fine. So let's move forward. Okay. Now, so still structure pointers are not yet done. I mean, there are two more things that we can do on structure pointers. So the first thing that we will do is that I can have another definition. I mean, for this, not for the structure pointers, but okay. Or how do we go about it? Let me do this the simple part, and then we'll take little bit complicated part. So let's say that I have some example structure. Let me call it as example struct. Okay, or yeah, I can call it as example struct. And in which case, so essentially there could be the point that we are now mentioning. I want to mention over here is that pointers can be inside the structure also. Pointers can also be fields inside the structure. Okay. We'll take this example and perhaps we'll come back to this example again later on. Okay, this is a little bit interesting for us. So, and what I can perhaps do over here is that I can have int pointer. So I can say that int, let's say iptr, and I can say float, I can say fptr. Okay. So what should iptr and fptr point to? Of course, they should point to integer pointer, and they should point to an integer and a floating point. So now the point here is this. Let's say that let me, instead of writing it over here, I write it above. So let me change that main function itself. Just like I wrote over here below this, I give this another declaration, and now I have, let's say, struct this. All this thing is done. If you allow me to declare somewhere in the middle, although this is not a very good idea, but let me do that. So let's say that I have struct example struct. This is the type, and I will say that I have ex. Okay. So ex is, maybe if you don't like this, I will write it above. Okay. Now this ex, what does ex contain? Ex contains two fields. Firstly, we need to remember ex itself is not a pointer. Ex is a structure. So the fields of ex can be accessed through dot. What are the fields for ex? They were iptr and they were fptr. So I can have ex.iptr and ex.fptr. So they should store the integer pointer and floating point pointer. Do I have any integer pointer right now over here? I don't care. So maybe I can store, I can have int I and I can have float f. So maybe what I can do over here is that ex.iptr I can put I, and ex.fptr I can put f. Okay. And yeah, so this I and f are assigned over here. Now, I don't know whether you have noticed that I and f are not yet initialized, but I can always, even before that, I can always assign the address of I and f are created. So I can always assign the address of I and f respectively to the respective pointers. So which I can do. Of course, what I should not be doing over here is I should not dereference the iptr and fptr. For example, I should not be doing. So how do I dereference iptr and xptr? So one way is basically I can say that star of ex dot iptr, and perhaps to make it more understandable, I can put something like this is equal to is equal to something I have to. So this is a pointer ex dot iptr, right? Star of that is some value. So I can say 10. This will set value of I also equal to 10, right? And then similarly for fptr, I can say that ex dot fptr is equal to 30. So let's say 3.7. So either this I could have done, or I could have done basically in respect of that, I could have done I is equal to 10, and I could have done f is equal to 3.7. As the respective pointers are stored in IPTR and FPTR, when I access them, the respective values would have always been given. Okay. So maybe I could have read these values also. Maybe I have some different integer j, and I could have, after this, I could have done j is equal to ex dot star of ex dot iptr, and let's say g is equal to star of ex dot fptr, and perhaps I will declare j and g also. So I will say I comma j and f comma g. Okay, so what are we showing over here? We are showing that the pointers can be part of the structure, but remember that when pointers are part of the structure, the fields themselves are pointers, but there is no structure pointer over here. I could have structure pointer also, but right now I don't have. Because of that, I am doing ex.iptr and ex.fptr. So the point to be remembered is that this I did, where is that? This I did when I had the structure pointer. Then I use the arrow. When I don't have structure pointer, I have to still use the dot, irrespective of what the fields are. Okay. So this is the second point that I want to make. Yeah. Any question at this point? Again, I'm asking. No? Okay. Okay. Please explain the last statement that you made. Okay, the last statement that you made, that I made, was this: that when, how do you decide that whether to use arrow or dot? So arrow you use when there is a structure pointer. So in this case, there is a structure pointer, so you use arrow. It's as simple as that. I don't care about what the fields are, right? So it's not on the fields; it's on the pointer. Which pointer? Whether you have structure pointer or structure. So so over here, we use just the structure pointer and then access the field by arrow. Correct. Whereas in this particular case, in the other case, uh, I had still the structure ex, and it so happened that the fields inside happen to be pointers. But that doesn't. That is what I'm saying. That doesn't matter. I mean, it's whether you have struct or the pointer is what matters. So you have the struct. You want to access the fields, at that point you have to still use the dot and not the arrow. Okay. So this was the point. I don't know what Gaurav is asking, but I will let the question pass right now because I want to increase the complexity step by step. Okay. So he's saying that if pointer is inside the, that is what the point I was making. It doesn't depend on whether the pointer is inside or not. I mean, what the field is basically doesn't matter on that. So the use of arrow does not depend on what your field is. Okay. The use of arrow depends on whether you have the structure pointer or you don't have the structure. Okay. That was a simple point. Just to avoid the confusion, I said that, but I don't know whether that itself created the confusion. So if struct pointer is there to struct where fields are PTR, I don't know what Omkar is trying to say, so I will let it pass. Okay. Don't worry. Don't jump the gun. Don't worry. We are going to increase the complexity step by step. So we are going to cover all cases. Don't bother about that. Okay. In case, but if you have a specific question, I can answer. But I don't think I can understand what Omkar is saying over here. So I'm passing it. So unless Omkar wants to put it more specifically, I will answer. Otherwise, we'll go to the next point. So the next point over here is that there is another way in which I can use pointer. Right? One way is basically this PTR I did and this ptr I used by ampersand of origin. But we know that, let's consider the case of integer pointer. Either the integer pointer can refer to the existing integer, which in this case it did by doing ptr equal to ampersand of origin. But we also know that the integer pointer could also point to a memory to memory which was allocated on the heap through malloc. So question is, can I allocate memory for structure on heap through malloc? The answer is yes. Okay. And how do I do that? So the way I will do it is basically, so I had to write something in bracket for typecasting, and a main important thing is I have to do the malloc. What is it I'm mallocing? Okay. So malloc what? Malloc, what did I do in case of integer? Size of int. So in this case, size of what? Int. Int was the type. What is the type over here? The type over here is struct point. So I am allocating memory which is of size struct point. Struct point is the type. So whatever memory that is required for struct point, that is being allocated. And then here there is a typecasting which is going to happen, which is struct point star. Because this memory which is allocated is of struct point type, so the pointer of it is struct point star. So this is what I need to do. And after I do this, perhaps this shift point have to be done. But remember that at this point, the fields are not yet initialized. So perhaps I need to do this. ptr arrow x is equal to, let's say, 2.0. ptr arrow y is equal to, let's say, 4.0. And then I'm trying to shift this point further by 1.0 and 2.0. So ptre, it was ptr. Okay. So I have a pointer to the structure. I initialize both the fields x and y, and then I shifted the pointer. And then perhaps after my work is done, maybe just to show that my work is done, I can show this dot dot dot, and I can, yeah. So I can have a pointer to the structure, and I can allocate, and just like I did in the case of integers. Okay. Only thing changes is access. I mean, the fields are to be accessed; they have to be done through arrow and the dots. No questions? So let me ask myself a question. Now, it's allocated. So the problem is, I mean, so just like you tend to ask me, what is size of int I write? And so you ask me the question, what is size of int? And I didn't answer that question. I didn't say that 2 bytes, 4 bytes, 8 bytes. I said that it depends on the system. In some systems, you will get size of int as 2 bytes. On some systems, you will get 4 bytes. On some other system, you will get 8 bytes and whatever. So similarly, you may ask me the question that what is the size of struct point? Actually, it is easy to answer me. I will say size of struct point over here is the sum of the sizes of the fields, which means size of struct point is, I will say, twice the size of float. Whatever is the size of float, it's twice of that. Okay. So this is the first cut answer I can give. Size of float, perhaps I will say that it is 10 bytes or something like that. Then you may say that struct point size is 20 bytes. Fine. Then let me ask another question. So let me have another structure. Let's say struct. Let's say, what did I say? Let's say first. And let me have char C. int I and float f. For the information purpose, let's say that char c takes c character takes, let's say, 1 byte, integer takes, let's say, 4 bytes, and although floating point numbers in most of the systems they take 10 bytes, let me write 8 bytes for a reason I'm doing this. Okay, now I ask the question that what is size of struct first. Okay, similarly what I can do is, yeah, so let it be right now. So I may ask the question, what is size of struct first? So I will say that answer is just like from the previous discussion. Answer is the sum of the sizes of each of the fields, right? Which means that 1 plus 4, 5, 5 plus 8, 30. So I may tend to give the answer which is 30. Incidentally, if I somehow check this, what is size of struct first? Okay, I can perhaps print that value. Or I can figure out basically, or rather it is just to know that 13 actually is the wrong answer. I will figure out that answer of 13 is wrong. But of course it requires 13 bytes. So the answer, basically the correct answer is that size of any structure for that matter, in this particular case, it will be greater than equal to 13. It may not be exactly 13. Sometimes it might be exactly 13, but some other times it could be greater than 13. And in this case, I will figure out that the example that I have taken, perhaps I will figure out that the size that I require actually is not 13 but 16 bytes. Now, why it happened? Okay, why it happened was because it's something called as memory alignment. So for easy access or for proper access, there are some extra rules that the operating system as well as the computer architecture defines. And the rule is something like this, that whenever you are accessing a data type, mainly the ones which are provided by the system, and it is true for other things also, but mainly for systems it is easy to understand. So when you are having a field inside a structure or any data type for that matter, okay, the data type basically starts from a memory address which is divisible by the size of the data type. Okay, what am I saying? I am saying that memory address should start from a value which is divisible by the size of the data type. Okay, so what would happen? Let's imagine for the time being that I am at location 0x1000. Okay, this is the, let's say, memory, the address which the system wants to give me. Is this address divisible by, so the first field is C, character C. So is this address divisible by 1? Of course, anything can be divisible by 1. So this is divisible by 1. So I will say that at this address, basically I can write characters. Now what happens? That I want to, after that I want to write integer I. But now the next address basically is 0x1001. Okay? And 1001 is not divisible by 4. Okay, because it's an odd number over here. So this cannot be allocated. So I will say that this is empty. Nothing is written over here. But that is also the problem with 0x1002, and similarly the problem is that 0x with 0x1003. Only when you go for 0x1004, integer I can be allocated. And now you will see that it requires 4 bytes. So 0x1005 also is basically part of I. So I will say that this is the first part of I. This is second part of I at this location. this is third part of a, and this is fourth part of a. And I'm kind of lucky that now I have the third field is float f, which is of 8 bytes, and 0x1008. So 1008 basically, it will allow me to store this particular float f over here. So I will have f here, and then I can imagine that this is the first byte of f basically, and then I can imagine that it will go on from 0x1008. It will go up to 100f. Okay, only when this point will be allocated. So essentially, allocate 100 where C is 0x100 is force will be allocated. Okay. Why did this happen? It happened because have the proper alignment, you will get this in one single block, you will get the integer. Whereas otherwise, you will change alignment. So just for few bytes, you will change alignment almost everything. So the runtime which is recovered, which is there, is quite high in that case. Okay. So here 16 bytes are required. Now the question is that so what are these then? 1001, 1002, 1003. So these are essentially blanks, right? So you will call it as blank. And but the technical word which is used is not the blank, but they are called as holes. So this is hole. No, you need not worry about. Perhaps that is another reason. I mean, here you should never do in case of structure. I mean, this is a very bad idea. And in general, also it is a bad idea. That if you have structure pointer, you want to print the values of x and y, you cannot directly do star of PTR. I mean, there is nothing like star of PTR. Okay, you cannot do directly star PTR equal to something. I mean, you cannot say printf percent d star of PTR. I mean, it will get prints. It will print something. I know, but then that doesn't make sense. Okay. Secondly, over here, as we saw, there are these 16 bytes over here, and there are these holes over here, which have been put up. So you may ask the question that does it not create problem while reading? I mean, when I want to write ex dot what was the name basically over here? First dot I is equal to something. Does it know that? Does the system know that it has to go to 0x1004? Yes, it knows, because it's the same rule that it applies while writing as well as for reading. So it knows that if first byte is C and it is this address, and then he has to skip these three things and it directly goes to the next address, which is divisible by the size of the integer, which is 1004. And then it knows that it has to go to this address over here, and from this address it needs to pick up the complete 4 bytes over here. So blindly it will pick up 4 bytes from here, one after the other, and likewise. So now the question is that, I mean, you required actually, the actual requirement was 13 bytes only, but you required 16 bytes. So perhaps could you reduce this requirement? I mean, can you get exact 13 bytes? Can the system give you exact 13 bytes? That is the question. And in which case it will happen. So I think I seem to see some comment. So let me see the chat box. So Omkar is asking what if we change the order, like int I, float f, and char c. So let's do that. So so if I may write struct instead of struct first, I may write struct second. Okay, he suggests me to use int. Omkar suggests me to use int, float, and char, if I'm not wrong. Okay. So in this case, what will happen? At 10000 4 bytes will be allocated. And now float F cannot be allocated at 1004. Can you see that? Because 1004 is not divisible by 8. So what will happen in that particular case is, basically if I want to write, so this is for the first. Let me have something called as second. Okay. So in 1000, I have I now. And yeah. Yeah. So I will have this I1 over here, I2 over here, I3 here, I4 here. And then 1004 is not divisible by 8. That is a float, right? Float was the next one. So next 4 bytes will be wasted. So here you have blank and hole. Next 4 bytes will be wasted, right? Yeah. So this is blank and hole. And similarly, up to next 4 ones, 1, 2, 3, and 4. These are blank and holes. And at 1008, you can allocate float now. So it goes on from F to 1. And then actually it is taking now more than 16 if you realize. Up to 100F, it will be basically F8. And then what will happen is 0x1010, then only you have chars. So this is taking 17 bytes. Okay, from 1000 to 1010. So now I want 13. What is the way out? I mean, this what Onkar suggested does not work, right? So
Sir, we can use float, int, and char.
yeah. So I could see in the chat box also. So if I use float, int, and char, then in that case the float would be from, as you can guess, it is from 1000 to 1007. And then at 1008, you can have the integer, which will go on up to 100C, which is 12 basically. C is 12, right? And then at 13, which is 100D, you will have the char C. And E and F are left out, right? D, is that correct? Yeah, 108 from 8, 9, 10, 11. Sorry, 8, 9, 10, 11 will be occupied by integer. So 12, which is C, will be occupied by by the character. Okay, and D, E, F will be left out. So in 13 bytes, basically, it will be done. So does it give you any hint? I mean, if I say that you are the one who have to design your structure, and in case you are worried about the memory, if you are not worried about memory, forget it. I mean, you just use the char C, int, float, if no one bothers about that. But if you are worried about the memory usage that you are making, and you want to reduce the memory usage, and typical memory usage will happen because of the structures. And if let's say that different types are given to you, so what do you consider as a good strategy to declare the fields inside the structure? The general strategy I'm asking, not about this particular problem. Yeah, so one hints which are coming basically that everyone is kind of guessing it from the example perhaps, is that highest data type first. And that is not wrong. Rather, the intuition over there, it's not only, I don't know whether you realize from the example that what is happening is when you pick up the highest size, then the relative wastage that you have could be reduced. I mean, this problem I could have modeled not as 1, 4, and 8. Perhaps I can do 1, 2, and 8 also. Okay. In that case, you can actually see that 1, 2, and 8. Then character C. Then at only one byte will be wasted. Basically, only one byte will have the blank and whole, and then 2 bytes. Okay, but again 2 bytes will be holes basically because I have to still wait for. So it will still take 16 bytes. Then if I do 1, 2, and 8, 11 bytes, but actually I will still require 16 bytes. Whereas when I have 8, 2, and 1, you would quickly realize that immediately after 8, 2 immediately are fitted in, and in the remaining part, 1 immediately gets fitted in. So what is happening is the remaining, as the sizes become lower and lower, you get more multiples of those numbers, right? That is essentially the idea. So in the higher multiples of in the multiples of higher numbers, within that there are many more multiples of the lower numbers. Okay, that is the whole idea, and that is why you can cover it up. Okay, within a smaller size. But initially you use random smaller sizes. Then what happens is for the larger size anyway you have to wait for the larger multiple to come in. Okay, so this is the intuition. I mean you can think over it. But in general, that is a rule of thumb. You can consider that if you are worried about memory, you can declare the fields of the structure in the reverse order, the reverse order of the sizes. Although this has nothing to do with the programmer, let me tell you. I mean, programmer is completely oblivious of that. Programmer just needs to know that, okay, there is a char C, I'm going to do first dot C or first dot I should get the character and integer. That's it. And that is what anyway going to happen because the rule for reading and writing is exactly the same. Okay. So there is, I think, one more question. What about array of structures? Float for second element cannot be allocated from you. I think you can think over it. I have covered what I was supposed to cover. I mean, if you want to expand it or extend it for array of structures, just make your judgment. I mean, these are the basic principles. You can always apply to the array. You can have complicated structures, not only array. We'll see some other complicated structures also. So I will say that as programmers, we are least bothered about that. Number one. Number two, if you are bothered at all, you can be bothered about size of the structure, and it will handle it that way. Okay. But remember, typically these rules remain, and you can have complicated structures. So generally, we don't get into what is going to happen in this case, etc., etc. I mean, see, in the worst case, you know that this is the memory that it is going to take. In the best case, you know this is the memory it is going to take. So as long as memory is anyway between basically these two numbers, I think we are fine, and it will be. But if you are concerned, then maybe you play with it. I mean, you say, okay, I reverse the order. Now you have another question. What about array of structures? Float for second element cannot be allocated from 0x. Yeah, it cannot be. So then in that case, it will have to perhaps go again from 16. But the idea is that for single structure, at least we all agree that it will be done. And imagine that if there are more structures, more characters, let's say it wants to fit in, maybe the operating system can fit in other characters. I mean, over there. It says that this particular structure is over at this point. So maybe not in the area of structures, but otherwise, basically, if I just had structure over here, then maybe after this, basically, if I do the reverse order F, I, and C, then maybe and there are some other characters I have C1, C2, C3. Maybe OS can fit them over there. So OS can make some optimization decisions in that particular case. Okay. So again, this is a point. As I said, this is not part of data structures. Is this part of C language? Perhaps not exactly in the sense that this is implementation issue. But C language implementers or C language designers knew that this particular holes may get created, and there are holes. So the simple point is this: that if you get the size of the structure, if you come to know the size of structure is higher than some of the fields, sizes of the fields over here, don't get alarmed. I mean, that is according to such rules. And then if you want to play with that, if you want to have some better way, then I told you that perhaps the reverse order of the decreasing order of sizes might help in that case. Okay. So I think let's do one thing. It's 50 minutes already. I mean, I think now I will have to perhaps start a different topic from this point onwards, which I don't want to do. So I think we will stop over here. In case there are one or two doubts, I may take them. And so are holes treated as free memory? The answer is no. And that is part of the structure. So for example, when you go like this, where is the 16 bytes? Yeah, first. So this complete stuff, 0x100 to 0x100f. This whole thing is one structure. So the holes or the blanks are inside the structure. Okay, they are not accessible to the outside or to the operating system. They are inside. It is property of the structure. Okay, so it is like saying that I have three houses in a colony, and every house is 800 square foot house. Okay, so how much is the length from this end to that end? It cannot be 800 into 3, that is 2400, right? I mean, there are some blank spaces between or empty spaces between two houses. Now, and every house has its own property. I mean, the empty space is its own property. So similarly, these blanks and holes are the property of the structure itself. Mm. So that is part of the structure. It's just that no one can access that. And system says that because system is following the rule of accessing, it accesses only those specific bytes only where the things are stored. So it doesn't care about these blanks. Okay, no one. So point is no one accesses. Okay, and it is part of the structure. So it is not necessary that memory filling start from 0x1000. In descending order won't work. But the rule might force it. I mean, if you write, for example, F followed by I followed by C, then in that case, first type being float, the operating system will hunt for the location, okay, which is divisible by 8. Okay, in that case, if you are somewhere in between 1002, it will say forget about it. I will start from 1008. But then in that case, remember that structure starts from 1008. So from 1002 to 1008, all those are free memory accessible by operating system also. So in that case, you are not wasting the memory because it is still available to the operating system. Okay, it is not the inside memory that you are wasting. And inside that, maybe there is some other memory you may waste. But that other memory from 1002 to 1008, which you have left, is left. I mean, it is part of the operating system. It is not your property. So that's why there is no wastage in that case. Okay. So the wastage is when the structure is there and there are blanks and holes inside. Okay, that is the this is the thing. So this I was answering to Akanksha, just for others to know. Okay. So this is, you consider this as general knowledge kind of thing that I told you. I mean, even if I don't tell you, this is, you would have perfectly fine, and you would have still written the programs, and you have written programs on structures. In the last semester, you had done the assignment. It didn't matter that you didn't know this particular part, right? So it's so fine. So we'll stop over here, and we'll meet tomorrow in the next class. Thank you.